Okay, here we are again. I've loaded up the document that I got from the tracker software, which is down here. I went ahead and saved and closed that previous tab. But this is the data that I got out from selecting all my individual points. Now, I could access the graph and some of the information and do some of this next part in Tracker, but again, getting some familiarity with Excel is going to be very, very useful overall. And I like being able to control exactly what happens in Excel so I can find out a bit more. What I'd really like right now is I want to try and get this data into a graph, because a graph is a really great way to try and sum up all of the information together. Now I could look and I could find individual velocities in between points, kind of like the system has done here, but that's also going to be based on kind of those points themselves. The graph, using a graph, is a way that I can try and take all of the data together at once so that I can get a better feel for what everything is saying on the whole. If I look at individual points, then if I've got a lot of errors in one or two of those points, they can cause a lot of problems with my end results. However, if I look at a graph and I can get a decent trend line from all of those points together, that should help minimize some of those fluctuations. So let's go ahead and do that. So I've got my data points here. This first column is time, so that's where it kept track of the time. It got that from the video settings. And here's the position, which the tracker software got from the spots that I selected based on my axis and my scale bar. And then I don't know exactly how it's calculating up the velocity here. I'll do what I can to try and find out. But this is the velocity that it was able to calculate up. I do not think it is actually what I originally thought, which is the difference in time, difference in displacement, so the displacement here divided by the difference in time, but we'll see. Let's get our graph though. So for that in Excel, I've got my numbers here. Scientific notation is perfectly fine, although if you'd like, we can take this, highlight all of them with a left click, start up here, left click and hold down, bring it all the way down. I'm going to right click, I'm going to go to Format Cells, and in number, the first one that comes up here, I'm going to go to number and let's go to, we'll call it 3 decimal places. There. So in case you're looking at the scientific notation, it's kind of hard to see what the numbers are. This might clear it up some. You don't have to do that. That's entirely up to you, but that's one of the things that we have control over here in Excel. Alright, I really want that graph, so I'm going to click over here away from my data, although that shouldn't really be necessary. Up here along the top, at least in this version of Excel, I've got, I think this is 2015, I can double check, but it's one of the newer ones. But even in the really old version of Excel, because I usually, myself, prefer to use 2003, you'll still have the same types of tabs or locations. What we're looking for is Insert. In particular, we want to find Insert, Graph, or Charts. In fact, in this, we've got Insert, that tab, and then down over here we've got Charts, and we've got a whole bunch of different types of charts. The one I want is the XY scatter chart. It's usually one that shows the axes for a graph, and then it's got a bunch of dots on there. So I'm going to drop this down, and I can look at different types of charts. Let's see, I'm going to go with, let's go with the straight line one with markers. Okay, so in this case, it's brought up nothing. It's a completely empty chart. Now, if I had clicked over in the data over here, it might have tried to automatically populate the chart. So you can give that a try, but sometimes Excel doesn't really realize what you want the chart to look like. That's okay, we've got a completely blank chart, and that's kind of what I prefer. So I'm going to right click, and I need to go down to Select Data. Now if you come in here and it's got data already, you can still right click. You'll want to right click on the data itself. I'll show you how to do that as soon as we've got an actual chart, and make certain that it's got what you want. But I'm going to do Select Data, and it brings up a box here. I'm going to click down here, Add. This is where I can actually add some of my data series. And it brings up this series name. I'm going to call this a position versus time graph. Then I'm going to do my X values. Now remember, we discussed in class position versus time. The first one is going to be my Y versus the second one. The second one is going to be my X. So for X, I want it to be time. I'm sorry, let me make certain that we're clear on this. There's a little button here off on the side that says Select Range, and when you click it, it goes into what's called Window Shade mode. You go over to, we said that needed to be time, so I go to my time column, I left click on the very first one and I hold down left click, and I drag all the way down to the bottom. Now it's put an outline around all of these. Basically it's saying I'm going to use all of those cells, those little blocks that I have there, for my data for time. And you'll see down here, now I actually have a graph starting to fill in. But I need my Y values as well. I have time put in there, now I need position. So I'm going to click Y values, it goes to window shade mode. I'm going to left click on the first one and hold down, drag all the way to the bottom. And then when I'm done, I can come back up here and hit this button to get back out of window shade mode. And you can see now we have a very nice looking graph. It's a curvy graph because this is a position versus time graph, and it turns out that we have an acceleration, so we're not going to end up with a nice straight line. This is pretty much exactly the graph that I want, so I'm going to click OK. Click OK. And here we go. Now here's my graph. Now if this came up in the first place, instead of having an empty one, that's entirely okay. You would have a graph that looks like this. What you want to do is come over here to one of your data points or the line, left click on that, and you'll see that it puts little things around it, and then you can right click and do select data, and that'll bring you to this same one. You'll have something here, but instead of clicking add, you can click edit, and edit will bring you to that same one and let you make certain that the X values are going to be your time and the Y values are going to be your position. Okay? So, in either case, you can get exactly what you want. Now, there's one final thing that I want you guys to do, because we have our graph here, and some of the stuff that we're going to work on in class is actually doing this next part, doing graphical analysis, doing things like best fit lines or trend lines. On the upside, Excel is programmed to do this sort of thing, and it can do some that are a bit more complicated, things that you wouldn't be able to do by hand because this isn't a straight line, it's a curvy line. So what I'm going to do is I'm going to left click again on my data. I don't think you have to, but I like doing that. Then I'm going to right click, and there's an option that says Add Trend Line. Go ahead and select that. Now in this newer version of Excel, it opens up some options over here. Now first off, by default it comes up on linear, and it's saying, okay, here's a straight line, a linear fit line, that tries to describe this data, with some of it above, some of it below, which isn't bad, except we know that this really isn't a linear relationship because we have a changing velocity. Hence why I said we had that acceleration. Our velocity is going to change, and we know that the slope of the position versus time gives us velocity. Well, if that's changing, it means we won't have a constant straight line. But on the upside, this is where Excel gets very useful, because I've got other trend line options. I've got exponential, I've got linear, I've got logarithmic, polynomial, power, and moving average. What I want you guys to go with for this position versus time, since we've got a curvy line, let's go with polynomial, and it should come up by default on order 2. It's a second order polynomial. In other words, it's something that has a squared value. Now you'll notice it's already redrawn the line for me, and I've got a fit line that now I can barely see the dots. You may not even be able to see them depending on the quality of this video, but it lines up with it perfectly. What if I try the exponential? My exponential, we can see my trend line doesn't really match up with my data. The linear still doesn't match all that well. Logarithmic? Apparently this doesn't like that one. Oops. Okay, so apparently it really didn't like that one. So add trend line. Now I'm back here. So logarithmic, it didn't even like at all. Power, it doesn't seem like it's liking that one. Some of these it may not be able to get a fit to. That's okay. We had a really good fit with this polynomial. Such a good fit that, again, you may not even be able to see it. It's order 2. And then the final thing that you really want to do is there's an option here that says Display Equation on Chart. Now, in older versions of Excel, you may have a couple of different tabs that come up on your trend line options. On the first tab, it'll ask you what type you want, and then you may have to select a different tab in that same box, and you'll see that it has the option for Display Equation on Chart. But what that does is it brings up the equation of that best fit line, and that's one of the things that we're going to work with. In this case, X, our horizontal value, is time, and Y is our position. So in this case, I have my position being equal to some value times, that's x squared, so that'd be time squared, and then plus or minus some initial value times time, and then there's another just regular number there. We'll talk a bit about that in class, how we can interpret this. But the long story short takeaway is, if you take a look at your kinematic equations, we actually have one of them that says that our displacement is equal to our initial velocity times time plus 1/2 acceleration times time squared. Well, if I subtract this guy over to the other side, that's actually a position minus an initial position spot, is what it's actually saying there. That's actually our displacement. So if I ignore this last number here, then I would have my displacement, my total displacement, equals some value times time plus another value times time squared. It turns out that this number is very close to 0, though not quite, because my clip may not have begun at time equals 0, so I may not have had a 0 velocity. Although this number is pretty close to 0, so I think we've got an all right fit. The important thing is this 5.76 should actually be 1/2 times my acceleration, because that's what's multiplied by time squared. So I could take this times 2. Just to be safe, I'm going to do equals 5.7623 times 2. I could do this with a calculator, but I don't have one on hand. And right now, according to this information, I find that the acceleration due to gravity, at least from my chart, from this data, comes up to 11.52, and then my units will most likely be meters per second squared, because this is time squared, my time is in seconds, and then when I set up my calibration in Tracker, I set it to meters. Now, we realize that this is off a little bit. We'll talk a bit about different sources of error, but one obvious one is, remember how I said it was kind of hard to select exactly where that little red puck was each and every time? I'm going to bring something up in Tracker in another video shortly, and I'm going to take a look at a couple of different ways that we can help reduce some of this, this error, right? If I don't click on the right spot for the little puck, then of course my numbers are going to be off a little bit. We may have some issues with the video. We may also have some issues with some of the other things that I've set up. One of the things that I did off camera, but I'm going to show you in using a different video on top of that, is our Tracker system actually has an auto track feature where you can actually click on something, it will identify what that looks like, and it will try and find it in all the subsequent frames. I did the exact same thing that you saw me do in the previous video to get this data, except I used the auto tracker function instead. Now, that isn't necessarily guaranteed to be better, but it's following an algorithm instead of just kind of trying to click on it directly like I was. Here are the results that I got from that. This is the data, and it's very similar, but not quite. You'll notice that it's a little more jumpy. It's not quite as smooth, but that's okay, because again, we may be a little bit off in one of the data points, but it's what all of our data together tells us that gets us a better idea. I did yet another second order fit line on this one, and the value that I have next to that is 5.0149. I'm going to multiply that by 2, because that value should be 1/2 A. So I'm going to multiply it by 2, and that should give me A. I ended up with slightly over 10 meters per second squared. It's still a little high, but it's definitely a lot closer than the 11.5. Now, there's still some systematic errors that I have in there. I'm looking at only 15 frames, and we saw that puck. It was pretty well spread out. Even with the computer trying to automatically identify where the puck is, possibly, not guaranteed, but possibly better than me trying to select it myself, even with all of that, there's still a lot of wiggle room in that. So, I'm going to make another video that shows you another way that we could work with this. But right now, this is precisely what we want to do. Now, you can go ahead and take the data from here, because I haven't shown you the auto track yet. Mimic this. I want you to get this graph, and what you can do is you can, once you left-click on this graph, you can print it, Control P, and you can print this. All right? I want you to print that, I want you to put your name on it, and that's what we're going to have for one of our, at least the turn-in stuff for this lab. All right? All right, see you in a minute.